In this video, we're going to learn how to solve word problems that can be modeled by three variable systems. So let's start off by reading through this first example together. It says an amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. There are 3 times as many seats in section B as in section A, and the revenue from selling all 23,000 seats is $870,000. It then ends by saying how many seats are in each section of the amphitheater. So this final question is essentially telling us what the 3 unknowns or the 3 variables represent. So here we're going to use X, Y, and Z, and our 3 variables represent the number of seats in each section. So I'm going to say that X represents the number of seats in section A. Y represents the number of seats in section B. And then Z represents the number of seats in the lawn. So that's what our X, Y, and Z represent. And once we know what our unknowns, or what we are looking for, what we're trying to find to solve that question at the end, once we find what those are equal to, we can then move forward and write 3 equations. So when I look at this situation, what I notice is that I have how many seats I sold and the revenue from that. So what I'm going to do is I'm going to write one equation that represents the number of seats that were sold. So here I have 23,000 total seats, and because X, Y, and Z represent the number of seats in each section, we're going to have X plus Y plus Z. So the 3 different types of seats all added together, those are equal to 23,000 total seats. So that's the first thing I can write an equation for. The second thing I can write the equation for is this cost here. So here we can see that we spent a total of $870,000, and our cost is calculated by using the $75 per seat in section A, $55 for section B, and $30 for the lawn seat. So here, if we take 75 times X, we'll find how much money we made in section A, because we have $75 per seat, and then we have X number of seats. And we'll add that together with 55Y, which that portion is $55 per seat in section B times Y, the number of seats in section B, plus 30Z, which represents $30 per seat in the lawn area, times Z, the number of lawn seats that we sell. And those 3 costs added together are going to equal $870,000. So just by knowing how many seats we sold and the cost, we were able to write 2 equations. Now, the third equation comes and it's hidden in this middle sentence in here. So I'm going to erase some of these extra purples I made here. And I'm going to focus in here on this detail right here. It says there are 3 times as many seats in section B as in section A. So that's a key detail to me, and I'm going to write that over here in green. So when it says 3 times as many seats in section B, it means that section B has more seats. So section B is going to be bigger than section A. So what I know is that the number of seats in section B, it is equal to 3 times the number of seats that are in section A. And if I write that out in words and then I put the variables in later, I can kind of start to piece together what this equation is going to look like. So the number of seats in section B is represented by Y. So we have Y is equal to 3x. So that's saying the number of seats in section B is equal to 3 times the number of seats in section A. So that is actually going to be our third equation over here. So we have now written our 3 equations. We can see them in there. We have the number of seats equation, we have the cost equation, and then we have the equation at the bottom, that's our special extra detail equation. So then from here, once we have this written, we need to then work through and decide which strategy is going to be the most helpful. And as we talked about previously, the strategy that is probably the most helpful here to start at least, is going to be substitution, because we have just two variables in this equation down here, and it's actually set up really nicely to substitute. So what we're going to do to start is we're going to use our substitution strategy. So we're going to say, okay, y is equal to 3 times x. So what I can do is I can go into the other two equations, and I can substitute my y value of being equal to 3x in place of y. So that's what I'm going to do first. This first equation becomes x plus y is replaced with 3x plus z is equal to 23,000. Now I can simplify that a little bit, so that becomes 4x plus z is equal to 23,000. So there's one of my new equations using that substitution. And then if I look at the next one, I notice that I have 75x plus 55, and then I'm replacing the y value with 3x plus 30z is equal to 870,000. And then if I multiply 55 and 3x, I end up with 75x plus 165x plus 30z is equal to 870,000. I then can combine the 75x and the 165x because they are alike terms. So I end up with 240x plus 30z is equal to 870,000. So I now have a second equation. So what I've done is I've replaced all of the y's with what y was equal to, which was 3x, into both of those top two equations, and I created a new two-variable system here with these two equations. So what I'm going to do now is I'm going to take 4x plus z is equal to 23,000. Then I have 240x plus 30z is equal to 870,000. And then from here you can utilize whichever strategy you would like. So one option is to solve for this z value alone here. So you would subtract 4x from each side and then substitute it here in place of the z. And the other option is to utilize elimination. It doesn't matter to me which you use. For this one, I'm going to utilize substitution because I just think that that might be a little bit easier. So I'm going to start here by subtracting 4x from each side. So I get z is equal to 23,000 minus 4x. And I'm going to substitute that in here in place of z. So I have 240x plus 30 times, in parentheses, 23,000 minus 4x is equal to 870,000. I then distribute, so I have 240x plus, that becomes 690,000 minus 120x, and that's still equal to 870,000. Then from here I can combine those x's together, so I get 120x, and then I can also subtract the 690,000 from each side. And from there I get 120x is equal to 180,000. And then I end here by dividing by 120, and I find that x is equal to 1,500. So remember, if we go back to the beginning of our problem and think about what x represents the number of seats in section A. So there are 1,500 seats in section A. So we've solved the first part of this, but there are still two more parts to go. So what I suggest you do next is that you go back into one of these two equations that contain two variables, and you substitute this x value in there to solve for z. So that's what I'm going to do to start. And I'm going to use that simpler equation. So I have 4x plus z is equal to 23,000. Well, I have 4 times 1500 plus z is equal to 23,000. So that gives us 6,000 plus z is equal to 23,000. Subtract that 6,000, and we find z is equal to 17,000. So z is our lawn seat, so that's telling us we have 17,000 lawn seats available at this amphitheater. And then finally, to end the problem, we have actually two different options here that I'm going to suggest. The first option is you can substitute x and z back into this original equation here, and that will give you how many section B seats you have. The other option is you can just utilize this third equation down here. We can see that y is equal to 3 times x. Well, x is 1,500. So what that's telling us is that we have 4,500 seats in section B. So we were able to solve for 1,500 seats in section A, 4,500 seats in section B, and 17,000 lawn seats satisfy all of the constraints in this particular situation. It gives us 23,000 total seats that give us a revenue of 870,000, and we also have 3 times as many seats in section B as in section A. Now let's take a look at example 2. 3 orders are placed at a pizza shop. 2 small pizzas, a liter of soda, and a salad cost $14. 1 small pizza, a liter of soda, and 3 salads cost $15. And then finally, 3 small pizzas, a liter of soda, and 2 salads cost $22. How much does each item cost? So if we look at this final question here, it's telling us what our x, y, and z values are going to be. Our x value is going to be the cost of an item, and I'm going to choose for it to be pizza, so it's the cost of pizza. And then my y value, I'm going to choose to be the cost of another item. I'm going to have it be the cost of a liter of soda. And then my z value is going to be the cost of a salad. So I can identify my x, y, and z values just by looking at the 3 items that I don't know the prices of. Then from here, I'm going to write an equation for each of these situations, and they're all going to be cost calculating equations. So to start off, I have 2 small pizzas, so the cost is 2x, plus 1 liter of soda, so that's 1y, plus a salad, so a single salad, so 1z, is equal to $14. So I've calculated a cost equation for that first individual that purchased some food. Then if I look at the second one, it says 1 small pizza, so 1x, plus there's 1 liter of soda, so 1y, plus 3 salads, so 3z, is equal to $15. And then finally, I have my third equation, which is 3 small pizzas, so 3x, plus 1 liter of soda, so that's 1y, plus 2 salads, so that's 2z, is equal to 22. So I start off, and my goal is to write my 3 different equations. And then from here, I notice that I have 3 equations, and I have all 3 variables in each. So this is a great situation to use elimination in. And if we're going to use elimination, the first thing that we need to do is we need to choose a variable to eliminate as we pair up our equations. And so I'm going to choose to eliminate y, because all of these contain a 1y, so it's going to be pretty easy to pair them up and eliminate them. So what I'm going to do is, it doesn't matter which one I pick to pair up with 2, I'm just going to pair up equations 1 and 2 and 1 and 3. So to start, I'm going to pair up equations 1 and 2, and I'm going to leave the first equation as is. So I have 2x plus 1y plus 1z is equal to 14. And then I'm just going to multiply this second one through by a -1, so that coefficient of y flips to a -1. So we have everything here multiplied by a negative 1. So I have negative 1x minus 1y minus 3z is equal to a negative 15. And then if I add straight down, I have 1x minus 2z is equal to a negative 1. So I have my first equation there that contains only two variables. Then from here, I'm going to combine equations 1 and 3. So the first equation is 2x plus 1y plus 1z is equal to 14. And then I'm going to multiply equation 3 through by negative 1 so that those y's have the same but opposite coefficients. So here we have negative 3x minus 1y minus 2z is equal to a negative 22. And if I add straight down, I get negative 1x minus 1z is equal to negative 8. So I now have two equations with two variables. So what I can do is I can take these two equations with two variables and I can create a new system using them. So I have 1x minus 2z is equal to negative 1. Then I have negative 1x minus 1z is equal to negative 8. And what I notice right off the bat here is I can actually solve this right away as is because it's already set up for elimination if I choose to eliminate x. So if I add straight down here, I get 0x, which is great. I get negative 3z, and that's equal to negative 9. So then I take a moment and I divide by a negative 3, and I find that z is equal to 3. And now, because this is a word problem, we need to go back and think about what z represents. Well, z represents the price of a salad. So what I've learned here is that a salad costs $3. So I've found my first cost and the answer to a part of that final question. So now what I'm going to do is I'm going to take my z value here of $3 and I'm going to substitute it back up into one of those two equations that contains only x and z. So I'm going to substitute it back here because it means I only have to multiply 3 by negative 1. So here if I substitute, I have negative 1x minus 1 times my z value is 3 is equal to negative 8. So I have negative 1x minus 3 equals negative 8. If I add 3 to each side, negative 1x is equal to negative 5. Divide by negative 1, and I find x is equal to 5, which again, remember I need to think about in the context of the problem. And so x is equal to $5 for that small pizza. So I've now found two of my costs. I know that a pizza costs $5 and that a salad costs $3. And now from here, if I take this $5 pizza and $3 salad and substitute it back into one of my original equations, I can find the cost of a liter of soda. So I'm going to substitute it back here into equation 3. It doesn't matter which equation you pick, that's just the one I'm going to utilize here. So I take 3 times 5 plus 1y plus 2 times 3 is equal to 22. Well, that becomes 15 plus 1y plus 6 is equal to 22. Well, I know that the 15 and the 6 can combine together to be 21. So I have 21 plus 1y equals 22. So if I subtract 21 from each side, I find that y is equal to 1, which means that it costs $1 for a liter of soda. So by creating my three equations and using my knowledge of three variable system solving, I'm able to determine that in this situation, for these three cost situations to occur, a small pizza would need to cost $5, a liter of soda would need to cost $1, and a side salad would need to cost $3.